Today we are going to explain one of the most dangerous type of corrosion, for which so many disastrous incidents happened all over the world. In many of my previous lectures, I have told you the failure and sudden collapse of building, road, flyover, the reason being the intergranular type of corrosion. So let us discuss how this actually type of corrosion proceed and what is the root cause of this kind of corrosion. By the name itself, intergranular, that is, we are talking about something happening in between grains. And if we want to explain it, we have to go back to 10+2. During your 10+2 days, when we used to discuss metallurgy, extraction of iron in blast furnace, in detail I will not discuss about it. Only the melting part I will be talking about to make you understand what is the root cause of this kind of corrosion. Let us start. You know, this is your molten metal, molten iron. As I have told you earlier also, suppose you are doing a business, you are having a blast furnace, and you actually prepare different kind of iron material based on the demand you get from different section of people. Suppose I have come to you and I have told you, give me around 100 tons of rod. You will definitely try to know the reason. In answer, I will tell, I want to make a building or residence, whatever it may be. So automatically you will ask me, what will be the specification of the rod? Suppose I have told it is 2.5 or 3 inch dia. So automatically what you will do, here you will make a die like this. This is your 3 inch. Now, as all of us know that, in the molten state, temperature will be on and around 3000 degrees centigrade. At this temperature, iron will be at a molten state, liquid, somewhat liquid form. Now, as you have supplying me rod and iron being solid in nature, then what you are doing, you have actually connected a die. Diameter is 3 inch. Now this molten metal will be allowed to pass through it. Now try to understand that. I am taking this part here to make you better understand. Like this. This is the molten metal passing through it. Now what is happening, you see. This is your environment. Now if we do not monitor this cooling stage, but cooling step, then what will happen? This is the area, this area and this area, 1. This again area, second area, 2. This is your third area. Try to understand that. This side and this side are very exposed to the environment, and therefore cooling down to room temperature will be very, very fast in both the sides. It will be followed by the adjacent side, 2 and 2. I want to mean, if the temperature of this molten metal, this side and this side, take 1 hour to become at per room temperature, so then 2 and 2 will take definitely more than that. Similarly, the central part, that is 3, molten metal of this part will take definitely more than that. If it is 1, it may be 1 hour 15 minutes, it may be 1 hour 30 minutes. What does it mean? The rod being formed is not uniform in terms of character. Try to understand that. Here, molten metal is in liquid form. Here, it is coming in the solid form. And this step is known as, you know that, solidification step. This is the step when all the mechanical property, physical properties, and metallic property as such of the metal is developed. And therefore, controlling this step, solidification step, is very, very important. As I have told you yesterday also, if you go to market to purchase something and if you are given 2 samples, one is made in US, another is made in India, without being partial, and if you are having enough money in your pocket, no doubt about that you will go for made in USA. The reason being, you have a perception in your mind, right from the beginning, the quality of a product of USA will be far, far better than India. The reason is that people in India, Europe and America do not compromise with quality, but we people in India can do anything for our self-interest. Actually, reason is that if we want to control this step, lot of money will be invested. Maximum investment, maximum cost will be involved over there. And therefore, a rod made in USA and a rod made in India, there will be a gulf of difference in terms of quality. In USA or Europe, they will be monitoring this step very, very carefully so that cooling of entire material, that is molten metal, go at a time, in a single go. The entire matter within this die will come down to the room temperature at a time. But if we want to do that, we have to monitor this cooling. But in India, we never do that. And therefore, the metal being produced here, that is metallic rod which is being produced here, it will be having some kind of defect right from the beginning. Try to understand that. If this is your rod, here, this is the weakest area and this is the strongest area. Under suitable condition, this weak area will definitely become your anode and this part will be your cathode. In presence of suitable electrolyte, the electrochemical cell will be produced, then anodic reaction, oxidation will take place, reduction will take place, and depending on the nature of environment, reaction will proceed. Now let us go in deep. Now after solidification, what happens? Let us discuss. If this is your rod which you have prepared right now, if we want to analyze it in terms of granules, grains, how they are, you know that. It will be like that only. Are you getting me? Like this. Like this. This is known as void. Perhaps all of you know that. This is called grain boundary. This is your grain boundary. And this will be your grain center. Try to understand that. I repeat, the gap among 3 grain is known as void. This meeting point is known as grain boundary. At the center of the grain is known as grain center. This is the rod you have used to make a building. Then what happened? Let us see technically. You know, grain boundary is the root cause of every problem. Try to understand. Because we firmly believe the entire impure material is concentrated on the grain boundary. Let us take a very simple example to make you understand. Suppose This is a plot of land of a person A. He has lost his wife few months back. He has two sons, A and B. Both are married. Initially they were living together. Now they have decided to go separated. Now what will happen? They will ask their father to divide the plot. Now say, it is the plot. It is for A and it is for B. If relation between A and B is not good, suppose one day what happened? A has gone to somewhere with his wife. And there is every possibility B will try to understand that. Change this boundary line towards this. And similarly, if this thing happens in B, A will try to make it like that. What does it mean? This area is the area of conflict. India-China border, India-Pakistan border. Every dispute is concentrated at the grain that is at the boundary of the two countries. So similarly, this grain boundary is the main area of conflict. It means entire impurities will be deposited at the grain boundary, as a result of which, under suitable condition, this grain boundary will become your anode, grain center will be your cathode. If suitable electrolyte is there, electrochemical cell is formed. Result is cracking at the boundary, cracking which is not visible from outside. You have made the building using this rod, but inside there is a crack on the grain boundary. Suddenly it will break down and the entire building will collapse. Corrosion of this type is known as intergranular type of corrosion. Try to understand that. The main reason being, it is tensile stress, residual stress, which is intentional, man-made. We could have taken care of this problem, but we have not done this. To earn more money, we do not spend or control the solidification step, due to which the metallic product we are producing will have some drawbacks inbuilt. This is what is known as tensile stress. And because of this tensile stress, if we use this metallic article in any building, bridge, flyover, one day under suitable condition, we will not know that, we will not understand the situation. Suddenly it will break, there will be a crack inside the rod, and suddenly it will break down with a catastrophic accident. And that is why this kind of corrosion is very, very dangerous, and the corrosion of this type is known as intergranular type of corrosion. The most common example of intergranular corrosion is exfoliation. Try to understand that. Exfoliation. This kind of corrosion is generally found in actually aluminium and its alloy. If any article is made of aluminium or this alloy, so this kind of specific kind of intergranular type of corrosion, exfoliation, is found. Actually what happens, as I have told you, it is also intergranular type of corrosion. What happens? Once grain boundary is generated, as we have shown there, this phenomena will proceed parallel to the surface. It is a surface phenomena. Suppose it is a grain, now it will proceed like that. Parallel to the surface, a single layer will go through through the surface of the structure. As a result, the upper layer, the specific layer will get corroded. Corrosion of this type is known as exfoliation. And therefore, if we want to actually control exfoliation, the most important step we may adopt, that is by applying suitable coating, this kind of corrosion can be controlled. And at the same time, we can choose a particular type of metal or alloy which will not be sensitive in that environmental situation. That is how we can control our exfoliation. Perhaps you might have understood what we have discussed today. In case of intergranular corrosion, it is the biggest problem in terms of accident all over the world. I have told you, collapse failure of building, bridge, multi-story building, flyover, any kind of catastrophic failure is mainly because of intergranular type of corrosion, and it is basically man-made problem. And if we want to save the universe, we have to take care of this problem very, very seriously. I am confident that you might have understood every point of intergranular type of corrosion. Please go through the video very carefully. If there is anything difficult, please get it noted so that we can discuss and clarify in the next